Hello everyone, my name is Salvador Gonzalez, and this time I'm going to present about the electromechanical design of a reverse osmosis machine in collaboration with Ozono Polaris. As the title says, we create a design of a structure for a reverse osmosis process. And this process, I'm going to explain it a little further the presentation. This project was about improving the efficiency, affordability, and space usage. This was a part in the project that was involved in automation and adding some control part, but I didn't focus on this area. Uh, I also added to this project, we made the casting of the components and mechanical frame for everything with the help of CAD software. The main objectives for the project, it was to explore past reverse osmosis projects given by the company and by my searches on the internet. The design and a new proposal for the machine accommodation, locate the components available in the worldwide market, and quote and choose the most suitable components for the process, for the prototype, and represent the designs in a specialized software. And in this case, I use AutoCAD Plant 3D. The main objectives give us these goals, which are familiarized with the reverse osmosis process, produce a more efficient, affordable design with a better accommodation. This is an important part because we wanted to make a different prototype for reverse osmosis processes because in the market there are different variations of it, but we want to make a new one. So it gets improved all the characteristics that I mentioned in the past slide. Also, we have a more realistic idea of the part that the machine is going to need to generate a cost estimation for the project and to make a representation for the design so we can visualize it in a better way. Okay, well, now going for the specifications and having the meaning of the reverse osmosis process. It is used in water treatment, where the water to be treated is induced in the reverse osmosis membrane with a certain amount of pressure and flux to separate the water into two flows. The first flow is the concentrate, which is high in salts, is the residual, and the second flow is the permeate, that on the other hand is low in salts, is clean, or is ready for the final use. The machines for making seawater drinkable will commonly have two steps. This meaning that having 2 times the pyramidal amount of membranes that we can see in the picture here in the presentation. Outside of the seawater application, and since we are going to treat brine water, the usual is to use a single step. A step can have two or more stages, where the concentrate from one stage becomes the influent to the next stage. Typically, half of the influent to one stage exists as permeate, and the other half continues as concentrate to the next stage. Therefore, the recovery of a one-stage machine can be estimated at 50%. For 2 stages, 75%, and for 3 stages, 87.5%. More than 3 stages are rarely used, so 2 are typically used in this process. The membranes are installed in housing tubes, which typically use 6 membranes, but can be manufactured up to handle 8 membranes in a serial way. The permeate of these membranes is collected in a central tube, and the collector of the membranes are interconnected axially. The concentrate from one membrane becomes the influent to the next membrane in the housing. Usually there will be several housings operating in parallel for each stage. As the recovery of each stage will be around 50%, the number of housings in one stage is usually the half the number in the previous stage. Okay, well, now the development of the design. First of all, I made the piping and instrumentation diagram that we can see in the right side. It was based on the image that we have here in the, I'm sorry, here in the left side. That is the sample diagram previously made for a similar project by engineers in the company. This diagram was really similar because it was an also reverse osmosis project, but they used it as a base and added all the characteristics that we wanted on the new project that we are going to develop. The next step that I did was localization and quotation of components with the help of use of internet and worldwide industry markets, also with some application for industry shopping. I was able to collect all of the information, and with having all of this, a comparison between Eastern and Western options was made. And as we can see in the left side, we have the Western options, and the Eastern side, we have the Eastern options. The list of components is not is really extensive, so I only put a little part in here. But well, this comparison was needed because we wanted to know the most convenient option for us, and taking into account the shipping of for Eastern options and discounts for wholesale buying. Now the development of this, the final design, it was made in Notability, another application that was is really easy to edit and to um, just make up all the addings, or just edit all the mistakes that we have, and have a better representation, a physical representation in the into the 3D or final product. Uh, as we can see, there's here's a 3D representation of it, and all the supports that we can see in the upper left side. It is not that affordable because of all the piping that was induced in here, and the space that it occupied. It was a lot. So another design was to be made, and that's what we have in the next slide, which is this one. We made into an arrangement of 3x3 accommodation for all the housings. In this diagram, we can see that we can add the bushings, the end caps, the hose lengths, the adapters, and the TE that we use alongside this prototype. Um, this was a better way to improve the process. Because of the usage of all of this, we decided that we were not going to use pipes, PVC pipes. Instead of this, we were going to use hoses, because of the curvature that it made, and because we wanted it to be high pressure. After this, we were able to make the 3D design. Here we can see it, and as we can see, it's not finished yet. We have all the frame, the mechanical frame for it. So you can support the automation part in some side, the panel control panel, and also the pressure pump and some of the housings. This was made also in AutoCAD Plan 3D, and is going to be the final diagram that we're going to use into the physical application. It's important to remember that the final objective of the project, of course, a more efficient design of reverse osmosis prototype, but the important aspect is the project to be affordable, viable, and reachable to companies and independent institutions that want to make water obtainable to communities or to personal uses. Well, that's everything I have for today, and thank you for your attention.